in Zoom chat. Well, now we will move to the next speaker, Kyungeon, who will be talking about data delivery service, ServiceX. So please, go ahead. Thanks.
Okay. Hi. Can you hear me fine?
Yeah, everything is good.
Okay. Okay. So I can talk about the ServiceX, which is change a little bit the gear. So the ServiceX is a scalable HEP event data extraction and transformation delivery system. So HEP event data means it basically supports various input data formats. It supports root and tuple, essentially CMS nano-AUD, and also Atlas X AUD, and maybe some future data formats we can have. And extraction means like it actually use FunkADL in the backend, so we can basically select columns and with filtering, and also it also does transformation, so it transforms the data into various format depending on the user's request. So it can transform into a array, or it can deliver in the format of Apache Parquet or root and tuple. And a delivery itself is on demand, so it can deliver to user directly to a user, or it can be in principle stream into analysis system, essentially from a remote place, like from the grid, or Rishu or XRoot protocol at the moment. And one of the key feature of ServiceX is it's scalable, so it runs on any Kubernetes cluster, so it basically scales up workers if necessary. So here is the example ServiceX workflow, because it can be, it can have different structure or different workflows, but here is I think most common example at the moment. So from a user make a ServiceX delivery request, essentially from a Jupyter notebook via a REST interface, and then ServiceX backend looks for a input data sets. It can be a Rusio or XRoot, and then it got the input file list, and then the generated code from FunkADL is that is applied on data format and also a query in FunkADL and so on. And it essentially creates a transformer pods, so-called in Kubernetes word, but essentially it's workers, and they are generated to process each file. So at the moment we produce 10 pods or 10 workers at first, and scales up if necessary. And once the transformation is done in Kubernetes cluster, the outputs are streamed into the object store inside the Kubernetes cluster, and then once it is ready, it starts to download to the user. So, and where is ServiceX? So ServiceX, as I mentioned earlier, ServiceX is deployed on Kubernetes cluster. So it is preferred to have enough resource to scale pods, and also very much preferred to be co-located with the data center for high network bandwidth, because as shown in this diagram, the input files are basically need to be loaded into Kubernetes cluster. And at the moment, there are two, I can categorize as two types. So standalone ServiceX deployment and integrate into Coffee Casa. So standalone is like the ServiceX endpoint or ServiceX itself is secured by own authentication system. So you need to apply for a access token and then to access that. But the good thing is this web API is accessible from anywhere, so you can access ServiceX from your laptop or wherever. On the other hand, Coffee Casa is it doesn't require any, I mean, special authentication because it is already secured by a certain system, but it is only accessible inside Kafka. And the input data format, we ServiceX support this. Yeah, it has a, I mean, separate deployments at the moment for each data format. So we have ServiceX deployment for root Entable, and or we have ServiceX for Atlas XAUD to access Atlas XAUD, or ServiceX endpoint to access CMS run on AUD. And we are currently working on to have a single deployment to access all different kind of input data. And here I listed the currently available ServiceX endpoints. So yeah, there are two types. So standalone one and inside Kafka. And for the Atlas collaboration, this requires basically you need to be a member of Atlas, or you need to be a member of CMS, and yeah, and also depending on the input data format you want to access, and they also various locations they are deployed. And here is the link to the endpoints, for example. Yeah. So let me move on to the ServiceX client library. This is basically the base library to interact with ServiceX. So this does basically makes a request to a ServiceX backend, and also monitors the progress of transformations, and also download files as soon as they are ready. And it requires Python, it runs Python 3.6 or higher. And yeah, you need to have basically ServiceX endpoint listed like here. And it is a configuration file, basically contains the endpoint information, and you can have like multiple endpoints in your configuration file depending on if you want to access Atlas XAUD or root endpoints, and optionally you can have, there's some feature, like it can have caching, and such kind of thing, information also can be placed in the configuration file. And for standalone endpoints, configuration file can be downloaded from web page. Let me show you quickly how it is being done for this is for Atlas endpoint. If I log in, okay, this is, I think, the first page. Not the first page, but you can basically the web interface that ServiceX provides for standalone type of ServiceX endpoints. And here you can see the dashboard, which include all the transformations, and also in the profile, basically my information, and also you can get API token, and you can download and so on. And this configuration file is if you download from the web, it is going to be the ServiceX.yaml, or you can change to the other names, and it is searched in that order. And you can place this file in your home directory or your working directory, and so on. And this is how the configuration file looks like. So you need to specify the name of endpoint and the actual address of endpoint, and if it is close to experiment, you need to have the token and what is the type of endpoint. Basically, if you download from the web, or this fills up a field. And one very nice feature ServiceX client library provides is local data cache. So once you make a ServiceX request and it downloads these files, and basically all those the queries and so on, they are basically stored in your local temporary directory by default. or you can change, like I mentioned earlier, you can change the path to the caching directory, yeah, somewhere else. And yeah, so the principle is, yeah, if you make the same query on the same data set, it won't create a new request. It just, yeah, copy from your caching directory. And one thing you need to keep in mind is this cache is amount, so it continuously fills up. So if you don't want to blow up your system or your storage, yeah, you might need to change to the some path that has enough space. And let me move on to the ServiceX libraries for your user, or your user need to interface, essentially. And the reason we have basically this user library is the ServiceX client library itself accepts so-called Castle query. So this Castle language is not intended, yeah, to be written by user. So we basically have so this Castle query is usually generated from the funcadl, or we have some kind of wrapper to be converted from TCAT style syntax. So these two packages basically can be installed, yeah, from PyPI, and yeah, with this command you can install these two packages. And yeah, let me start with funcadl ServiceX package. It basically utilize all the funcadl expression that Mason talked just before to basically to generate Castle query, and it basically provides for different backends. So it has Omroot backend, and also for XIOD backend, and also for CMS Broadband IoT backend. So once you have a funcadl query, basically it translates into the Castle language that is relevant for the backend type. So yeah, here I put some hands-on. You can in principle try by yourself. I think it's pretty fast, although it's gonna be retrieve data from remote. So let me, here I import the libraries, relevant for the Omroot type of data backend. So here I imported ServiceX and funcadl ServiceX. And then here I listed the input data set. This is Atlas Open Data. And then now I define the ServiceX data set with the input data, and transforming the image doesn't need to be path. So just the name of backend. So this backend name should be basically the same what you put in the config file. And then for Omroot data set, you need to pass the tree name you want to access. And here I define Omroot data set object. And then now it's time to write your own funcadl query. Here I just make a very simple query, but as you learned from previous talk by Mason, you can make it very complicated, and you can make very efficient selection depending on your need. So, and then here you need to define what is your what data format you want to get out of this out of ServiceX. So here I ask as a pandas data frame, and then nothing actually been executed yet. So it is, and if I ask for a value, now it is finally making a request to the ServiceX backend. So once I ask for delivery, and there are basically two rows. First row is for the transformation, and second row is for download. So yeah, it is essentially transformed inside the Kubernetes cluster in Kubernetes cluster for ServiceX, and then it is being downloaded here. So the output looks like, yeah, this. You have, yeah, two columns left on PT and eta, and then basically it delivers for, yeah, column. And basically I can do a pretty similar thing with TCAT syntax, because I worked on this because it's, in some cases, yeah, it is yeah, easier or needed or easier to integrate into the existing, yeah, system. So this TCAT to Castle basically translate the TCAT syntax into Castle query, and it basically supports, yeah, I think most of expansions we usually use, and the usage is pretty simple. You just need to, yeah, execute this translate function and pass a tree name and the list of columns you want to deliver and the selection you want to apply. But there's yeah, a big limitation. I say, the thing is, it only works with root and full or root at the moment. And the other thing is, it is only compatible with scalar type of branches, because it doesn't know whether it's, yeah, it is vector or scalar in advance, so it cannot, yeah, it cannot translate into, yeah, relevant, yeah, functional language if it is vector type. So yeah, I think I can recycle the, yeah, ServiceX data set I loaded before for FunkADL. So let me import this Castle, TCAT to Castle library and translate. And the Castle query actually looks like this. It's, yeah, pretty complicated and readable quite. And now once I have a query and that I have the data set defined earlier, and then I can ask to deliver as a, yeah, also in pandas data frame. Yeah, likewise, it also creates two rows, one for transformation and the other one for download. Yeah, basically the output is the same as before. And in some cases, you might want to force not to use your local cache, and if something changes in the data side or so, you can force to submit ServiceX delivery request again. And for this time, let me ask in the format of Parquet. Since I said to ignore local cache, it forced to make a ServiceX request, and then it basically returns the path to the Parquet file in your and then you can basically see those Parquet files. And what I have tried is basically the ServiceX deployed in Kafka Kaza endpoint, and in principle, we can use, as you can see here, there's a ServiceX config file, already prepared for you. So this is the endpoint we are using at the moment, but this is not exposed to the outside. So let's try ServiceX endpoint, which is a standalone, but let's try only for one available for open data. So this is the endpoint, open to, I think, open to everybody. And this is basically the one listed here for open data. This is at the moment deployed at SSL River. And and then this basically this cell writes another ServiceX file, but and basically specify the different different endpoint. Yeah. And then let me define another ServiceX data set. In this time, I would use the ServiceX endpoint at the SSR river. So if I basically do the same, now it basically makes the ServiceX request to the river. And for the standalone ones, there's a dashboard. You can see this is basically the request that I submitted. So you will see basically how transformation is going. So once it is done here, it is completed here, and then basically it is downloaded already to your basically here, and the output is the same. And the last thing I want to talk about is ServiceX data binder. Basically, ServiceX client libraries like FunkADL, ServiceX, or Ticket library, Help Wrapper library, they are in principle complete. You can do whatever you want to interact with ServiceX backend and also handle all the outputs. But this data binder is just to make your life easier when you need to run very large number of data sets, like full run-to physics analysis. So it basically handles all your ServiceX requests and also they deliver data from a single configuration file. And this is how the configuration file look like. So there are two main blocks. The general one is you need to basically specify the backend name you want to process from using this configuration file. And then the output directory, you want to basically deliver the files. And then also you need to specify what is the output format you want to store the ServiceX delivered data. And then here you need to specify what is you can define the samples basically. So you can, like your analysis, you can define the name of the sample, and then here you can list of root UDIDs in most of your analysis case, list of root UDIDs for this sample, and then the name of the tree you wanna basically access, and then the FunkADL query, but without data set and also without the value. So the middle FunkADL, And also at the same time, you can also use Ticket style syntax if you use columns or filters. And there are other options you can also use. And let me show you how it works. So the usage is pretty simple. You just import the data binder. It can be installed or skip install, and then you just wrote this your configuration file and then ask to deliver that. So this is one quick hands-on that I want to try. So ServiceX, ServiceX request to the SS River open data endpoint, and then the output directory is under the same folder, and I want to deliver in the format of root, and this JEP root columns is for the if you have same name, same prefix for the branches like JET PT or JET ETA or something like that, it automatically JEPs those branches to make one. And then also the output pass files can be generated for the subsequent analysis if needed. Then you can define, here I use open data, son of data for data and Monte Carlo. So let me write this file. I guess it's that now. Let me restart that. this file is loaded, and now if I make a request, so since I have like 5, but I think some of them are already cached, so it submits ServiceX delivery request, and if you refresh your dashboard, some is already done and one is still running. So basically it generates it generates many requests at the same time.
Sorry,
so
in case we have 2 minutes left, and I think it's just a problem that you will need to restart server.
No worries. I mean, this is the last cell I want to cover. So it basically returns the list of files, and then you can basically look into those files. So wrapping up, ServiceX basically provides really whole new experience in accessing and retrieving data from remote. And I mainly focus on ServiceX itself, but it can be already being integrated into other frameworks. And ServiceX is still improving, and so stay tuned. That's all.
Thanks a lot for such amazing talk. And I want, please go ahead and check out questions.
I think maybe Ben, you have better answer for this question.
Sure. I am so excited about this presentation, seeing how all this has come together. So the first question is hilarious. Does ServiceX presume POSIX storage for outputs? Actually, internally, it is using an object store, and the library, the ServiceX front-end library, will download it to your laptop. But there's it can retrieve just the URLs to the object store. So if you've got some ideas for how to use object store, I think it's such a great way of storing this data. And then I'll just touch on the next one, and I'll need help on the other ones. But server-side cache. So right now we don't have it. It's actually a very simple fix. We weren't sure if there's a tremendous use case for it, but all we have to do is, if the data set identifier that you send and the selection string that you send are the same, then we could hash that and just point you to an existing run, and it's already sitting there in the object store. You'll be hearing a talk later about Skyhook, where you can actually, because all this data is now in nice columnar format, you can even do sub-selections inside the results into the cache to be smarter. This was the original Rob Gardner and Mark Neubauer idea of intelligent data delivery, where the cache is intelligent. And if you want a subset of the data that's already been cached, we should be able to pull that out and give that straight to you without having to redo anything. I want to phone a friend.
Server-side cache.
That was what I just answered, was server-side cache.
Yeah.
I might have to phone a friend on the why the query is not a Python Lambda. I think it's...
Yeah, so for that one, I can comment. So this is probably an artifact of earlier versions. So the issue is that FunkADL needs to be able to get the abstract syntax tree of the Lambda function. And if Python only stores the Lambda function as bytecode, essentially, if you pass it as an argument. But so that's why it used to be only as a string, because then you could parse the string as using Python's AST library. But there's a trick to actually, in most cases, retrieve the code of the Lambda function. So for example, in an IPython notebook, it's possible to just read the code by getting the line number where it is. So it should work without the quotes now. It used to not do that. And then for the other question, I can't provide too many details because this is what Gordon works on, but it is possible to provide custom user C++ functions, for example, for the XAOD backend.
yeah, I think that's about it.
So the last question left, I'm not sure if we replied on it. Is there any way to pass defined precompiled C++ function to ServiceX? Maybe something similar we're using in root by a root G interpreter declare.
Yeah, so this is what I meant. The simple answer
Yeah.
is yes, it is possible. There's an interface to pass metadata, and one of the possible metadata like things that you can pass are custom functions, so that you can pass C++ code to the backend and it will compile it as with the rest of the code that it generates.
Cool. So I think we are